Okay, for 2.6, we're wanting to verify that this is indeed the matrix form for the spin operator in any in direction. So before we get into that, I'm going to do a review on some Calc 3 type stuff. If you either haven't taken Calculus 3 yet, or like me, just kind of forgot some of the stuff, we'll go over it again. So um, we've done this whole 2D coordinate system a lot, and we know that we can split a vector. So if we have this vector r, we can split it up into x and y components, right? So if we want the x component of this vector r, that would be r cosine theta. If you want the y component, that would be r sine theta. All right. So this is Cartesian coordinates. And if you were to have like cylindrical coordinates, so if you had like 3D, like a 3D cylinder, you had some height, then the height would just be the height. So z is just z. But then transferring that into spherical coordinates, which is what we have here. So if you can kind of picture this, we sort of rotated this these axes right here. So the x-axis is now coming out of the board, if you can imagine that. The y-axis going left and right, and the z-axis is going up and down. That's kind of just the convention here. So this vector here, this vector s, which is going to represent our spin component vector, is coming out of the board. If you can see that, it's coming out of the board and kind of just laying down. This dotted line is like the projection falling between the x and the y axes. Hopefully that drawing is kind of okay. So we don't deal with this projection part of it here in spherical coordinates. So we don't have this r anymore. So we can kind of get rid of that. So we can't really do this exactly. We need to find what this r is. But we do know some things. So if we draw a dotted line right here, we can tell, you can kind of see this whole plane right here. We can tell that this dotted line on the top is the same as the bottom dotted line. That's what was r. I'll rewrite r. So this is r. And r, we know, is going to be, we know the hypotenuse is going to be s. So opposite over hypotenuse, well, that's going to be sine. So r is s sine theta. These are now no longer called theta for whatever reason. Physicists wanted to change the angles here. So this angle is now phi. That is between the x and the y, from the x, positive x-axis going up to the positive y-axis. That's going to be the angle phi. And then so this angle here from the z-axis going to our vector, that is going to be what we call theta now. So these have changed, no longer theta. These are now phi. And we no longer have an r. So we have this instead of r. So we can just input that there. So now our x is going to be what r was. It was r. Now it's going to be s sine theta. And then cosine phi. All right, so then that's our x. So our y is going to be, we have another r there. So r is going to be s sine theta, cosine, no, gotta read, that one right there, sine phi. Okay, so really we have x is still cosine, y is still sine, but this r had to be replaced by something else. So that something else going to be our sine theta. We plug that in for what was our r before. So hopefully that's a little bit easier to remember. I know you've probably seen this big long equation that looks impossible to remember. Our z is going to be the adjacent. So we have our s here. Our opposite is going to be this r term. The adjacent is going to be our z, how much z we have. So our z is going to be s cosine theta. All right, and those are going to be our three terms. So our Sn is going to be Sx, is going to be our Sx times sine theta cosine phi plus Sy sine theta sine phi plus Sz cosine theta. All right. So this big nasty formula here is the whole thing put together. So now we can kind of swap some things out. So let me write it up here. So Sn equal to, well, Sx, we know that that's the Sx operator, which we know is h bar over 2. Sx is 0, 1, 1, 0. Sine theta cosine phi. Then we have plus our Sy operator, which is h bar over 2. 0, negative I, positive I, 0. And I wrote too big here, but we have sine theta sine phi plus, I'll write down here, our Sz operator, which is going to be h bar over 2, and 1, 0, 0, negative 1, cosine theta. Okay, so that's just the same thing with our operators plugged in. So I'll erase this one for now. You can erase these drawings also. And actually, because I've erased the drawings, I'll write this up here. H bar over 2, 1, 0, 0, negative 1, cosine theta. All right. So now we can just go ahead and combine all of this together. Because if we were to plug these values in, so just multiply each term, so that would be 0, sine theta cosine phi, sine theta cosine phi, 0, and so on. Then just add the matrices together. It would give us just one big matrix. So let's go ahead and do that. So n equals, all these are going to have an h bar, so we'll factor out the h bar over 2. Okay. Then we're going to have a 0 here, plus 0 here, plus cosine theta there. So cosine theta. For here, we're going to have a sine theta, cosine phi. We're going to have a minus I sine theta sine phi, and 0. Here, we're going to have a sine theta cosine phi, and then plus I sine theta sine phi, and 0. And then we have a 0, and a negative cosine theta. All right, so we can simplify this a little bit. So n equals h bar over 2. All right, cosine theta, can't simplify that at all. Cosine theta stays. This right here, we can factor out a sine theta. So we have sine theta cosine phi minus I sine phi. Right here, we can factor out a sine theta. So sine theta, we have cosine phi plus I sine phi. And here, we just have negative cosine theta. Okay, and now you can see, hopefully, that this is Euler's formula right here. Cosine phi minus I sine phi. Because remember this, e to the I x equals cosine x plus I sine x, and e to the negative I x equals cosine x minus I sine x. And that's what we have right here. We have the second one. So this is going to become Sn equals h bar over 2 that stays cosine theta. This stays sine theta. And this can turn into e to the negative I phi. And right here, we have a sine theta. And here again, we have the positive one. So we have e to the positive I phi. And then here, we have negative cosine theta. And hopefully, that matches what we have here. Cosine theta, sine theta, e to the negative I phi, sine theta, e to the positive I phi, and negative cosine theta. So that worked.